boundary conditions at x equals L. So we have 5 boundary conditions and for 5 constants. So this is much simpler than 8 equations for 8 constants. Okay? Much, much simpler. Analogously, if I will have now 10-span beam, in the 10-span beam, I will have how many constants? 4 constants, A1, A2, A3, A4. Okay? This. And every support, which is 9 we have, yes? Each of them is introducing one reaction. Okay? So will be 13 equations. Okay? But 13 equations are much easier to solve than 40 times 40. Right? So this method is reducing dramatically number of constants. You may want to write down. This method is reducing dramatically the number of constants to deal with. Okay? Yes, sir. Yes, you want back? Fine. Say it again. Can you repeat? Fine. Now, x equal L will be like, yeah, okay. So it's not exactly the boundary condition. It is like intermediate condition or also like continuity condition. Yeah. Maybe we will say continuity condition. You are right. Thank you very much. So first of all, A1 and A3 equals 0. Do you remember that? For simply supported case, A1 equals 0 and A3 equals 0. So that's very beautiful. We reduced from 5 unknowns to 3 unknowns because 2 unknowns are 0. So you may want to write, we reduced number of unknowns to 3. So then what we have is as follows. Look, please. W of x equals A2K2 plus A4K4 plus A5K4 alpha x minus L0. So now I substitute conditions. W at 2L equals 0. So I substitute here 2L, 2 alpha L. Alpha L, if you remember, equals lambda. Then I have A2K2 of 2 lambda, A4K4 of 2 lambda, but here will be just lambda because 2L minus L is L, so will be just lambda. Then second derivative equals 0 at 2L will be A2. Now K2 first derivative is K1, first derivative of that will be K4. K4's first derivative is K3, then K2, etc. From K4 we get K2. So we get K4 2 lambda, K2 2 lambda, A5 K2 lambda. And we have also W of L equals 0. When I say W of L equals 0, this guy does not come into consideration. Okay, because I mean from the left it equals 0. So A2K2 plus A4K4 equals 0. So these are the three conditions. Please write it down. Three conditions. Sorry. Now determinant must be 0 in front of this coefficient. So determinant equals this. K2 2L, K4 2L, K4 of 2 lambda, K4 of 2 lambda, K4 of lambda. K4 of 2 lambda, K2 of 2 lambda, K2 of lambda. Here K2 of lambda, K4 of lambda, 0. So an equation is like this. When I open this, K4 of 2 lambda times K2 square of lambda plus K4 square of lambda minus 2K2 of 2 lambda times K2 of lambda times K4 of lambda, and that equals 0. So this is an expression. Now the work is not finished. I mean, I cannot just leave it here at this point. I mean, that is. Now there is K4 of 2 lambda and K2 of 2 lambda. Yes, K4 of 2 lambda and K2 of 2 lambda. We better express these values in terms of functions of 1 lambda. And here comes also the homework. So K2 of 2 lambda, I am asking what is this, and K4 of 2 lambda. And homework will be to check these expressions. Please write down K2 of 2 lambda equals this, K4 of 2 lambda equals this. That is what I'm maintaining. And please check whether this is right or not. Yeah, I think that here should be not 1/2, but 2. Okay? 2. 2 times K1 lambda, K2 lambda, K3 lambda times K4 lambda. K4 2 lambda equals 2 times K1, K4, K2, K3. So what is our homework assignment number? Homework set? 17? Okay. K1, K4, K2, K3. 2 lambda. sir? Do you mean here? On the right-hand side, everywhere is lambda. And on the left-hand side, in both cases, is 2 lambda. Can you come and show me there?
K1 or K4?
Oh, K4. Do you remember we need K4? That is 4. Sorry. K4 of 2 lambda. Now I would like you to, that is 17.1 and 17.2, part 2. Please check that the frequency equations that we talked, okay, that means this one. Remember this one. When you substitute K4 of 2 lambda and K2 of 2 lambda, that expression can be factored. Unbelievable result is obtained. That can be written as a product of 2 expressions, K2 square of lambda minus K4 square of lambda, and then K2, K3 minus K1, K4. That also please check. So that can be factored. That means that frequencies of this 2-span beam coincide with solution of this first equation equals 0 and second equation equals 0, of this and this. Now, unbelievable thing happens. This expression, K2 square minus K4 square equals 0, please check. That is an equation for simply supported beam of length L. This is a frequency equation for simply supported beam of length L. Please check in your notebook when we did simply supported. And this one, K2, K3 minus K1, K4, is nothing else but frequency equation for simply supported clamped beam. And you did this, I think, either as a homework or we did it in the class. So what we are obtaining is as follows. So this equation is reducible to sine lambda equals 0, this one. And this equation is reducible to tangents lambda equals hyperbolic tangents of lambda. This one to sine lambda, this one to this one, this expression. Now, what we obtained is an unbelievable conclusion. If there is a 2-span beam with a middle support, then its frequencies, it has frequencies of simply supported beams, that is simply supported at both ends, but length, half length, L. And simply supported clamped beam that has a length of L. It has both frequencies. 2-span beam has frequencies of this 1-span beam and this 1-span beam. It incorporates both in itself. That is a magnificent conclusion. The student is asking, do you mean if we would use these 8 equations with 8 unknowns, would we get the same result? If you make a comment, it has to start and end somewhere. You should make a full sentence. What is a full sentence? Yes, but it does not lead. I mean, it just utilizes previous results. Yes, this method utilizes previous results. Yes. Yes. In the second part, I would like to prove that the frequency equation that was written before, and that is this one, this frequency equation, that it can be factored as like this. That this equation, k for 2 lambda, etc., that it is factorable as product of these 2 expressions. I would like you to show that this expression and this expression are the same. Can you write down first and then ask question? First write this, what I asked, and then you ask question, because otherwise you did not know what to ask about. I would like you to show that this expression and this expression are the same. Now, if you have any questions, please ask, because first we better write down. No, we don't write. What does it mean, just write 1 lambda instead of 2 lambda? I don't understand this. What kind of question is that? We have to put, instead of k for 2 lambda and k to 2 lambda, expressions that we have, that you have to do in first homework, and then use those results to show that this equals this. Do we understand what is the problem? We will continue next time, and in few remaining minutes, I would like to stay here and answer your questions about homework and other things.